So in this short lecture, we'll talk about whether work done by a system depends on the path or just depends on the two states. For example, we can reach, so let's say this is my initial state 1, where you have the pressure P1 and volume V1, and you want to reach state 2 where your pressure is P2 and volume is V2. So you can reach state 2 from state 1. Here there's several paths you can take, but here we are talking about 3 paths. So let's say you can go at a constant pressure from 1 to 3 and then come to from 3 to 2 at constant volume, right? Or you can take a path at a constant volume V1, so you go from 1 to 4 and then you go from 4 to 2. Or you can take some arbitrary path from 1 to 2 straight. So there are 3 ways you can reach there. In each case, your initial state or state 1 is P1 V1 and final state is your P2 V2. So we know from earlier slides that work done is the area under the PV diagram, right? So let's take case 1. So we started from state 1 at a constant volume, we reached 4 and then we reached 2. Then work done is equal to the area under the PV diagram, and this is the in the pink you see that's the work done, right? Now I take another path, like go from path state 1 to state 3 and then state 2, right? So now work done is again the area under the curve, and this area is much bigger than the area here. Or the third stage we can take from here to here, and this area is in between these two. So one conclusion we can make here is that the work done by a system during a transition during a transition between two states depends on the path chosen. It depends on the path chosen. Okay, so that's very important. So work done by a system during a transition between two states depends on the path chosen. Here, suppose we want to change the volume of a certain quantity of an ideal gas from 2 liter to 5 liter while keeping the temperature constant at T is equal to 300 Kelvin. So this figure here shows the two different ways in which we can do this. In this figure, gas is contained in a cylinder with a piston with an initial volume of 2 liters. Right? We let the gas expand slowly, supplying heat from this electric heater to keep the temperature at 300 Kelvin. After expanding in this slow, controlled, isothermal manner, the gas reaches its final volume of 5 liter. So this is my state 1, this is state 2, and the process, it absorbs a definite amount of heat from this heater. Now let's consider here, this is my state 1. Different process we are talking about. The container is surrounded by insulating walls and is divided by a thin, this is thin breakable partition into two compartments. The lower part has volume 2 liters and the upper part has volume 3 liters. In the lower compartment, we place the same amount of gas same amount of the same gas as here. Okay, and again at the same temperature, 300 Kelvin. The initial state is the same as before. So here the initial state 1 and here initial state 1, they are exactly the same, right? Now we break the partition. The gas undergoes a rapid uncontrolled expansion with no heat passing through the insulating wall. So no heat passes through the insulating wall. The final volume is 5 liters, the same as in this figure here. Temperature remains the same, 300 K. But however, in this process, the gas does no work during this expansion because it does not push against anything that moves. This uncontrolled expansion of a gas into vacuum is called free expansion, and we will discuss this later. The experiments have shown that when an ideal gas undergoes a free expansion, there is no temperature change. Therefore, the final state of the gas is the same as in this figure. So final temperature here is also 300 Kelvin. But in both cases, we go from state 1 to state 2. Here also state 1 to state 2, but we reach different results, right? Here heat is transferred, there is no heat transferred. Here is work is done to move the piston, there is no work done. So we can conclude here like work, heat depends on the path, right? On the path it has taken, right? Okay. All right. So like work, heat, we can add here, heat does not only depend on the initial and the final states, but also depends on the path it has taken. All right, great, good.